Hello there, I am Jonathan Shi, and here's my demonstration of my changes to the N-Body project. First, let's take a look at what a normal N-Body program looks like. If you look at the structure of the command, you have the Java command, followed by the class name, followed by the amount of frames it goes for, and the time difference in each frame, and then the full name of the file. And here we have a nice little kaleidoscope as provided to us. One of the changes I made was to make calling the N-Body class a lot easier. Instead of having all these parameters, you simply need to say N-Body Extreme and then the name of the file without saying data or .txt before and after respectively. If you notice what's been going on the actual screen while I was talking, everything exploded. This is fine and perfectly normal, intended behavior. It's a feature, one might say. I did this because one of the suggestions was to support elastic or inelastic collisions. These collisions, unless you consider the heat release from them, from the explosion, they're not really elastic, but they are actually inelastic. When two bodies collide, one of several things can happen, and the most important two things are: one, if one object is sufficiently larger than the other, the smaller of the two objects will be completely destroyed in an explosive fashion. If the two objects are of comparable size, then both objects will split into a bunch of smaller parts. And that particular collision is also explosive. So ultimately what happened is when these objects attempted to kaleidoscope, they collided into each other and they exploded, and having not enough gravity to sustain their initial orbits, they all fell into the sun. And since the sun is very large compared to all of these things, the sun felt no consequences. One other part of the behavior of the splitting function is that, as I said earlier, it is in fact inelastic, meaning that momentum is actually conserved. So here in all these really laggy frames, you can tell that there are little parts of squirrels going everywhere. And the velocities of these particles are actually randomly generated, but they are generated in such a fashion that at the end of the day, all the particles produced by any given collision will have the same momentum as the body that initially produced them. Now, Star Wars fans who have seen the movie Rogue One will know that Scarif is the site of an Imperial base during which there's a climactic final battle. And here is a depiction of how the battle might have went were it not for one of the franchise's most iconic vessels. All these things just run into each other. Ultimately, the Rebel fleet is destroyed, and I'm sure the Imperials have more things somewhere out waiting to back up their fleet to replenish these destroyed Star Destroyers. Anyway, you'll notice this anomalous little window here that has the WASD keys and this little text that we'll ignore for now. But if we press WASD, which you might be able to hear me doing right now, nothing happens. Let's run this sample again.
Sir, we're detecting a massive object emerging from hyperspace.
Look, it's a Death Star. I pressed J, it emerged out of hyperspace, and it turned the tide of the battle, except those destroyers insisted on maintaining their orbits and destroying each other. Anyway, in the movie, Grand Moff Tarkin orders...
Target the base at Scarif. Single reactor ignition.
So let's do that. I'm pressing space to charge it. I can fire, and Scarif is destroyed, which did not actually happen in the movie. And absent the gravity of that planet, the Death Star drifts off into oblivion. One more thing I forgot to mention earlier is that in order to maintain some semblance of efficiency, as would be necessary in situations where you have a lot of particles generated by collisions, one thing I did was that when an object moves off screen, although it is physically possible for it to return to the realm of the canvas, just for convenience and to save a little processing power, I decided to remove objects as soon as they go off canvas. So, we have seen only a fraction of the Death Star's power on Scarif. Now let us turn to the planet of Episode 4, A New Hope, Alderaan. A peace-loving planet out here in the middle of nowhere. Boom, Death Star. You'll notice that when the Death Star jumps out of hyperspace, it will enter into a circular orbit around the largest body in the system, since there's only one body in question, and it is therefore by default the most massive one. So let's fire on Alderaan. Actually, before we do that, I need to demonstrate something. These WASD keys actually do serve a purpose, and that purpose is to accelerate the Death Star. It will move around. This is another one of the suggested features, that the Death Star is essentially just a large spaceship, right? So it is in fact controllable by myself. You can see in that window over there what buttons I'm pressing. And you'll also notice that the laser of the Death Star, the direction I'm aiming, is following my mouse cursor. So let's aim that cursor at Alderaan and fire. So all that's left is kind of an asteroid field. One last demonstration for one more feature. You'll notice that in the command line, I've been calling these things with one short argument for it. DS stands for Death Star. This planet, Hosnian, if you don't know, is the planet in Episode 7 of Force Awakens where the capital of the New Republic is located, and it is destroyed by the Death Star 3, which is, in fact, Starkiller Base, and that's what SK stands for, Starkiller. Unlike the Death Star, Starkiller has a red laser, which Hosnian will shortly find out about. And there we go.